So, hello, a very good evening to all, and welcome to the class. Right. So, welcome to class 11. So, in today's class, basically, we are going to revise chemical bonding in a very short way and try to cover all the important topics related to this chapter and also try to solve some numericals. Right. So, we have a two class today and tomorrow, like Saturday and Sunday. So, in two classes, basically, our focus is on solving more, right? Practicing question more, right? So we are going to try and solve all JEE, NEET and advanced questions related to the chemical bonding chapter with some concept as well, right? So मैं कुछ कॉन्सेप्ट भी बताने वाला हूँ, सारे इंपॉर्टेंट चीजों को भी बताऊंगा और उसके साथ ही साथ हम लोग इन क्वेश्चंस को भी सॉल्व करेंगे। ठीक है, तो चलिए शुरू करते हैं आज का क्लास। चलो, so I'm Vivek Tiwari, and this is the chemical bonding crash course lesson number one. So this is the first part of this, the chemical bonding crash course. So what are the basics theories of chemical bonding, right? So in initial, I'm going to, explain all this thing in the detailed way, and later we are going to solve some question related to this concept as well, right? So formation of chemical bond and bonding in them arise many questions, right? Like why do atoms combine? Why are only certain combination are possible? Why Na combine with Cl to form NaCl only? Why not NaCl2? Why MgCl combine together to form MgCl2 only, not MgCl? So these type of questions were arising, right? So in order to answer such question, different theories and concepts have been put forward from time to time, out of which the important one are as follows. We are going to be discuss them, right? So in order to answer such question, different theories and concepts have been put forward from time to time, out of which the important one we are going to discuss in this, right? So I hope you get the basic idea about the basics theories of chemical bonding. Hmm? Sure. Now, the main point of this approach are as follows. So, the first theory that we are going to discuss is Lewis approach, also known as Octet rule. So, what are the main points of this approach, right? So, the outermost cell of an atom is called the valence cell, and the electron present in it are called the valence electron, right? So, this is one of the most important thing is that is the outermost cell of an atom is called the valence cell and the electron present in it are called valence electron. Okay? Now, the inertness of the noble gases is due to their stable configuration, right? That is due to presence of 8 electrons, except helium having 2 electrons and they complete their duplet, right? So basically, the outermost cell of an atom is called the valence cell, the first point you need to remember, and the electron present in the valence cell are called valence electron. Now, the next is the inertness of the noble gas. Why noble gas are inert in nature? Why they do not react with any other? It is due to their stable configuration, right? That is due to presence of 8 electron except helium in their valence cell. Clear? Now, on the basis of Lewis proposed that the element having the 8 electron in their outer cell having complete octet are chemically inert, right? So Lewis, according to the Lewis, those having the 8 electron in their valence cell are chemically inert, just like the noble gases. Now, hydrogen is the only exception which has the 2 electron in its valence shell, and this is called popular as octet, right? So, hydrogen, in case of hydrogen, this thing is helium, right? Always remember it, not hydrogen, helium. So, helium is the only exception which has a 2 electron in its valence shell, and this is called popularity as octet. Means all the if you consider the all the element of the 18th group, then all having 8 electron in their valence shell, except helium, they have 2 electron in their valence, right? So elements that do not have a complete octet have a high tendency to attain this configuration, either by losing or gaining or sharing electron to the atom of the same or other element, right? And all these are used as mean in bonding. So basically what you need to remember that the element that do not have a completely octet have a high tendency to attain this configuration, either by losing or gaining, or we say sharing electrons to the atom of the same or other element, right? So this is why octet rule came into the picture, right? Every element has a strong tendency to behave like a octet rule, right? What is this octet rule? What is this inert gas? That is the noble gas group 18 element, having 8 electron in their valence electron. So all the other element has a target to achieve this configuration, noble gas configuration. And to achieve this configuration, they either lose electron, right? They either lose electron, they either gain electron, or they share electron, just to make 8 electron in their valence. So I hope this is clear. What is the Lewis approach? Huh? What is the Lewis approach? Why Lewis approach is very important? How atom combine? Okay. So this is very important. Now, let's see some concept-based question on the basis of Lewis theory. So we know that, for example, if you want to draw the diagram of ozone molecule, right? So how will you draw the diagram of ozone molecule, right? On the basis of Lewis dot structure. So we have a 3 oxygen, right? 1 oxygen, we have a 2 oxygen, we have a 3 oxygen. So we have total 3 oxygen atom. We all know that oxygen having electronic configuration 2, 6, right? So how many valence electron of oxygen are? That is 6. So oxygen having 6 valence electron. Now, everyone wants to attain their noble gas configuration, right? Everyone wants to attain their noble gas configuration, that is 8 electron in their valence shell. So what they do? So in order to achieve 8 electron, how many electrons they need more, beta? They having 6 electron, so they need 2 more electron now. If they get 2 electron, then they also behave like a noble gases and having 8 electron in their outermost shell. Huh? So this is all about, that is 2 6. So O is equal to 2 6, right? Now let's see. Here we have oxygen. So we know that oxygen having 6 electrons. So total we have how many oxygen? We have a 3 oxygen. So total number of valence electrons. Total number of valence electron. So total number of valence electron is 6 into 3. That is equal to 8. Okay. The total number of valence electron is equal to 6 into 3, which is equal to 8. Clear है यहाँ तक? Now we know that we have a 3 oxygen atom. So if they combine with the single bond, right? So single bond, single, right? So how many bond we have? We have a 2 bonds. So we have a total 18 electrons, and we know that in one bond कितना electrons लगता है? एक bond में 2 electrons लगता है. So आप 18 में से कितने माइनस करोगे बेटा? जल्दी करो. तो 18 में से 2 इलेक्ट्रॉन यहाँ से माइनस हो गया, राइट? 18 में से 2 इलेक्ट्रॉन यहाँ से माइनस हो गया, 2 यहाँ से माइनस हो गया. तो टोटल कितने माइनस हो गए? दैट इज 4. तो 18 में से 4 माइनस करो, कितना बचा? दैट इज 14. नाउ अब इसको देखो, इस ऑक्सीजन को, दिस इज नाम दे दें, चलो. दिस इज ऑक्सीजन नंबर 1, दिस इज ऑक्सीजन नंबर 2, दिस इज ऑक्सीजन नंबर 3. पहले मैंने सबको एक एक बॉन्ड लगाया, अभी चेक करेंगे कि क्या ये करेक्ट है कि नहीं. ठीक है, तो एक एक बॉन्ड लगा दिया हमने सबके बीच, ऑक्सीजन ऑक्सीजन के बीच, और हमने देखा कि क्या स्ट्रक्चर बनना चाहिए. तो टोटल हमारे पास 18 इलेक्ट्रॉन थे. 18 में से 4 इलेक्ट्रॉन हमने यहाँ पे लगाए. कैसे? 2 बॉन्ड बनाए ना, तो एक बॉन्ड में 2 इलेक्ट्रॉन होता है, तो 2 बॉन्ड में 4 आ गए. तो टोटल वी हैव 14 इलेक्ट्रॉन. नाउ ऑक्सीजन नंबर 1, इसको कितना इलेक्ट्रॉन और चाहिए बेटा, अगर इसको ऑक्टेट कंप्लीट करना है तो देखो 2 इलेक्ट्रॉन तो एक बॉन्ड से मिल रहा है, इसको 6 इलेक्ट्रॉन और चाहिए, तो इसको चाहिए 6 इलेक्ट्रॉन. सिमिलर इसको भी चाहिए 6 इलेक्ट्रॉन, और इसको चाहिए 4 इलेक्ट्रॉन. तो टोटल कितने हो गए बेटा? 6 6 12 4 16. यानी इलेक्ट्रॉन तो चाहिए 16, और हमारे पास है टोटल कितने? 14 है, यानी -2 आ गया. मतलब कि कहीं ना कहीं 2 इलेक्ट्रॉन्स की कमी हो रही है, यानी 0/0 आना चाहिए, तब हमारा आंसर सही होता है. यानी इसमें किसी ना किसी एक बॉन्ड को डबल बनाना पड़ेगा। ठीक है, अगर और दो इलेक्ट्रॉन की कमी होती है तो दो को डबल बॉन्ड बनाना होता है, बट सिर्फ दो इलेक्ट्रॉन की कमी हो रही है तो किसी भी एक को डबल बॉन्ड बनाना पड़ेगा। तो आप कैसे बनाए, चलो तो ऐसे देखते हैं, ऑक्सीजन, ऑक्सीजन, ऑक्सीजन। सो वी हैव वन, इसको ही डबल बॉन्ड बना देते हैं, इसको सिंगल बॉन्ड करते हैं। नाउ अगेन वी हैव टोटल 18 इलेक्ट्रॉन्स। 18 में से कितना माइनस कर दो, 2 टू 4 टू 6, 6 तो पहले माइनस कर दो, कितना बचा 12। नाउ सेंट्रल एटम को कितने चाहिए, ऑक्सीजन नंबर 3 को, किसको चाहिए, दो तो चार दो छह, एक चाहिए बस लोड पेयर, तो इसको दो दिया, माइनस करो दो, बचा कितना 10। इसको कितना चाहिए बेटा, सिर्फ 4 इलेक्ट्रॉन चाहिए, क्योंकि 4 तो मिल रहा है ना दो बॉन्ड से, तो 4 माइनस करो 6, और इसको एग्जैक्टली 6 चाहिए, दो, दो चार और दो छह, तो इसको 6 चाहिए, कितना बचा 0। so this is how you draw the structure, so this is the structure of O3। समझ आया सबको किस तरीके से O3 का स्ट्रक्चर बनाया। यानी O3 के स्ट्रक्चर में हमने क्या सीखा कि एक O है जो डबल बॉन्ड ऑक्सीजन के साथ जुड़ा हुआ है और एक सिंगल बॉन्ड ऑक्सीजन है, राइट। और इसमें कितने कितने, इसमें है दो लोन पेयर, इस पे है तीन लोन पेयर, और इसमें है सिर्फ एक लोन। ठीक है, तो दिस इज हाउ विल यू ड्रॉ द स्ट्रक्चर ऑफ O। समझ आया सबको कैसे ड्रॉ किया, चलो। नाउ on the similar way, if you want to draw the structure of some other compounds like CO2, we know that C, and this is O, this is O. So C having electronic configuration 2 comma, oxygen having electronic configuration 2 comma 6, ठीक है, oxygen having electronic configuration 2 comma 6, and carbon having electronic configuration 2 comma 4. So carbon require 4 electron, where oxygen require 2 electron only, right? Oxygen require 2 electron. So here we can see that oxygen having 6 electrons, right? So carbon having 4 electrons. So out of this 4 electron, they will make one bond with this electron, that is double bond with this, double bond with this. Now, now their octet complete. So carbon having 4 bond, 1, 2, 3, 4, 8 electrons. Oxygen having 2 bond, that is 2 to 4 and 4, 8. Here also 2 to 4 and 4, 8. Carbon having no lone pair because it have only 4 electrons, और सभी के सभी चारों इलेक्ट्रॉन बॉन्ड फॉर्मेशन में ऑलरेडी लगे हुए हैं। तो इस तरीके से तुम CO2 का स्ट्रक्चर बना सकते, ठीक है। Similar, if someone asks how will you draw the structure of CO3 twice negative ion, carbonate ion, right? So how will you draw the structure of CO3 twice negative? देखो, we have C, we have O, we have O, we have O, right? So we have a 3O and 1 carbon, CO3. And given that twice negative. So out of this, twice negative means what? बेटा किस पे दो नेगेटिव चार्ज है, so always जब भी नेगेटिव चार्ज गिवन होगा, always assume that this negative charge on the most electronegative element. So out of carbon and oxygen, which one is more electronegative? Obviously, oxygen is more electronegative now. So these two negative charges on the oxygen only. So suppose this oxygen having the negative charge, this is also having the negative charge. Only two oxygen having the negative charge, right? So we know that oxygen having electronic configuration 2 comma 6. And what about oxygen negative? So they having electronic configuration 2 comma 7. मतलब oxygen negative wants just one bond, one electron to complete their octet, where oxygen wants two electron to complete their octet. It means they need just a single bond. They also need one single bond, but they need double bond. They need double bond. And carbon having, we know that 2 comma 4, so all 4 electrons. One electron here, one electron here, 2, and 2 electron here. So total 4 electrons are consumed. So this is the structure of CO3 twice negative ion, right? So this is how will you draw. Just remember one thing, everyone wants to complete their octet, and in order to achieve this octet, some loses electron, some gain electron, and some share electron, right? So this is all about the octet. Now, violation of octet rule. So in some cases, octet rule is not possible, right? Octet rule is may fail also. So what is the violation of octet. ठीक है, फटाफट देखते हैं. So as the general precipitation this octet rule is acceptable to most of these cases. However, the octet rule is violated also in a significant number of cases. Right. For example, beryllium and boron have less than 4 valence electrons. Hence, their octet cannot be completed even if they bind with their full strength. Right. For example, if you're considering beryllium, so beryllium, we all know that only they belong to the group 2. So they have only 2 electrons. Right. So when they combine with the 2 electrons, when they combine with the fluorine atom as well, then also they will form BF, right, BeF2. So in this case also, for example, this is Be, this is F, and this is F. So we all know that fluorine having electronic configuration 2, 7. So they want just 1 electron. Beryllium having electronic configuration beta 2, 2, 2. So they having 2 valence electrons. So if they bind with this 1 electron with this fluorine, 1 electron, this fluorine. So fluorine having 8 electrons, no issue. This fluorine also having 8 electrons. But this beryllium having only 2 electrons. They do not have any lone pair of electrons. So they do not have octet. So they have a incomplete octet. Incomplete octet. So they having incomplete octet. So we can say that they have a total 4 electrons in octet. How? 2 electron with this fluorine, 2 electron with this fluorine. So only 4 electrons are present at the octet, not 8 electrons. So these are the violation of the octet rule. Similarly, when the BF3 combine, they will form BF3. BF3. So in case of BF3 also, they having only 6 electrons. Right? They having only 6 electrons in their valence shell. And we can say that their octet is also not complete. So this is the violation of the octet. तो क्या बस इलेक्ट्रॉन कम है तभी वायलेशन होगा? इलेक्ट्रॉन ज्यादा है तो क्या होगा? अगर 8 इलेक्ट्रॉन है तो ऑक्टेट रूल फॉलो करेगा. गुड. 8 इलेक्ट्रॉन से कम है देन ऑक्टेट रूल फॉलो नहीं होगा. ये ठीक है. और अगर 8 इलेक्ट्रॉन से ज्यादा भी हो गया ना तो भी वो ऑक्टेट रूल को फॉलो नहीं करेगा. उसको बोलते हैं हम लोग एक्सपेंडेड ऑक्टेट. राइट. दैट इज कॉल्ड एक्सपेंडेड ऑक्टेट. सो लेट्स सी. In molecule with the odd number of electrons, the octet rule is not satisfied for all the atoms, right? That is in the molecules like NO, NO2, ClO2 negative, as they have two center, 3 electron bond. So in this also they have a deficiency of electron. Like if we draw the structure of NO, so we have a structure of NO like this, right? That is N having 2, 5 electrons and O having 2, 6 electrons. So oxygen want 2 bonds. So here we have a 2 bond. So oxygen completes their octet. But what about the nitrogen? Nitrogen having 5 electron out of this 1, 2. 2 electrons are used in this bond formation. So they are left with the 3 electrons. That is 2 and 1. In this also they have a deficiency of 8 electrons. Right. In case of NO2 also and having deficiency of electrons. So we can say that in both the above cases, there are total 7 electrons in the nitrogen octet, right? 4 electrons from this and these 3 electrons, 7. So they have a deficiency of 1 electron. Okay? So they are also the violation of the octet. Now, if the number of compounds, there are more than 8 valence electrons present in the central atom, this is termed as expanded octet, right? So in a number of compounds, there are more than 8 valence electrons present in the central atom. And this is termed as expanded octet. Now, what is this expanded octet? So this tendency is seen in elements beyond the third period of the periodic table, as they have a vacant d orbital for the bonding. Right? How will you understand this thing? Let me explain this with an example. Right? Here we have a PF5, right? So we know that phosphorus having valence electron of 5 because they belong to the 15th group, right? So they having the electronic configuration like 2, 8, 5. So they having the 5 valence electron, right? And we have a 5F also. So F having electronic configuration 2, 7. So they just need 1 electron and they have a 5 valence electron. So they can donate 5 electrons, right? Or we share 5 electrons. So we have in this, we can see that this is 1 bond, 2 bond, 3 bond, 4 bond, 5. Total 5 bond. 5 bond means what beta? That is 10, right? 5 bond. एक bond में कितने electrons होते हैं? 2. So 5 bond means what? That is 10 electrons. So total in this 10 electrons are involved. So we can say that it is expanded octet. In case of SM6, so 6, so they having 12 right? So in this, the 12 electrons are involved. So these are the example of the octet, or we say expanded octet, right? Here also we can say that sulfur having 2 to 4, 4, 6, 8, 8, and this is 4, 4, 8, 8 to 10, 10 to 12. So here also sulfur having 12 electrons. Okay, in the valence shell of sulfur. So this all are the example of the expanded octet. Clear है? सबको समझ आ गया? What is expanded octet? What is octet? What is the violation of this? ठीक? चलो. Now it is often seen for the some compound like carbonium ion, benzene, that the single Lewis structure is unable for the representation of the molecule, especially for explaining all its properties. Then many structure with the similar energy position of nuclei, bonding and non-bonding pairs of electron are drawn, with the condition that each of this will explain same properties of the compound. Right. So these are called the resonance structure. So these structures are called resonating structure, or we say the canonical form, and the hybrid of this structure is considered as the real structure of the compound. Like carbonate ion is the resonance hybrid of the following canonical form. So here we can see that it's a very easy thing. This is the CO3 negative ion. We just draw the individual structure, right? अभी भी बनाया था इसको. So this is the carbonian ion, that is CO3 twice negative. CO3 twice negative. So this having double bond here, this having double bond here also, and this having double bond here also. So we can say that this double bond can be either of those three oxygen atoms. So they will show resonance structure, right? So if you draw, if you want to measure the bond length of this carbon oxygen double bond, in generally what we know, that is carbon 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 single bond, carbon carbon double bond, carbon carbon triple bond. So triple bond having the shorter wavelength than after double bond, and longest way longest length is single bond. This thing we know, right? But in case of the resonance, जहाँ भी हमें resonance देखना होता है, always remember, अगर मैं पूछूं कार्बोनियन आयन में कार्बन ऑक्सीजन का लेंथ क्या होगा, इसका लेंथ क्या होगा और इसका लेंथ क्या होगा, तो इन तीनों का लेंथ सेम होगा, राइट? बिकॉज दिस हो रेजोनेंस. रेजोनेंस का मतलब ही यही हो कि ये डबल बॉन्ड यहाँ भी रह सकता है, इस वाले ऑक्सीजन पे भी रह सकता है, यहाँ पे भी रह सकता है, राइट? सो दे ऑल नाइदर ये प्योरली सिंगल बॉन्ड है, ना ही ये प्योरली डबल बॉन्ड. ठीक है, ये कुछ इस तरीके का है जो हमने बनाया है structure, resonance hybrid, right? So when the compound in which the resonance occur, they do not having the different bond length. They all having the same bond length, right? Because in this the bond is neither purely single bond or purely double bond, right? Similar case occur in benzene also. Benzene also, this is carbon carbon double bond, carbon carbon double, carbon carbon double. But it doesn't mean this bond length and this bond length having the different bond. No, they all having the same bond length, right? Because this double bond is delocalized. Sometimes this is there, and after some time they delocalize. Delocalize means what better? They come to next one. That is यहाँ आ गया, फिर यहाँ आ गया, फिर यहाँ. So they are delocalized, right? So we can say that this is the resonance structure, how it goes on. So from the concept of resonance, the bond order of the molecule or ion can be calculated. So from the concept of resonance, if you know the concept of resonance, then the bond order PU of a molecule or ion is calculated. How? So bond order is become total number of bond between the two atoms in all the structure divided by the total number of canonical forms, right? So bond order, how will you find bond order? That is the total number of bonds between the two atoms in all the structure divided by the total number of canonical forms, right? Let's see with an example. Suppose we have this question is from the JEE in 2022, and it is one of the very important question, right? So what the question asks basically, beta? So in this question they are asking chlorine react with, right? That is the chlorine react with the hot and concentrated NaOH and produces compound X and Y. Compound X give white precipitate with the silver nitrate solution. The average bond order between Cl and O atom in Y is. So you need to find the average bond order between Cl and O atoms in Y. ठीक है? चलो. So we know that we have 3Cl2. This react with 6NaOH. You can say that hot and concentrated. Okay. So this is the 3Cl2 react with plus 6NaOH hot and concentrated. So whenever the Cl2 react with the NaOH, what you will get better? Will get this thing we learn in P block also, and this type of questions you are going to solve in the P block element, right? So अभी शायद P block तुम लोगों ने नहीं पढ़ा है, but इसीलिए थोड़ा सा reaction तुम लोगों को मुश्किल लगे. But once you read P block, then you are able to write this reaction, right? So this is the 3Cl2 plus 6 NaOH. This will give us 5 NaCO. ठीक है? And NaClO2. NaClO3 plus 3H2. Remember, whenever the chlorine react with NaOH, hot and concentrated, you get 5 NaCl plus NaClO3 plus 3H2. In this question, they're asking chlorine react with the hot and concentrated NaOH to produce compound X and Y. Compound X give white precipitate. So, ये compound X है पक्का. How will you know? Because this will react with AgCl3. Right, this will react with the AgCl to form what they form. They form NaCl plus AgCl, right? So they will form AgCl. So they react with AgNO3. Let me write this AgNO3. So they react with AgNO3 to form AgCl plus NaNO. So this AgCl is white precipitate. White precipitate, AgCl. So this is compound X. And what about compound Y? So compound X give white precipitate with the silver nitrate solution. And the next is compound Y. This one. Okay. So we get the compound X and compound Y. Now, the average bond order between Cl and O atom in Y. So you need to find the average bond order of Cl and O atom in Y. So we have Y is equal to what? That is NaClO3. That is Na plus ClO3 negative. Okay. So we have a Y is equal to NaClO3, NaClO3 having Na plus and ClO3 negative. Okay. Na plus and ClO3 negative. Now, how will you draw the structure of this ClO3? On the basis of Lewis structure only. Right. So ClO3. So let me draw the structure of this. So we have Cl. We have a 3 oxygen. 1, 2, and 3. Out of this one having negative charge. Let us make this oxygen having negative. So you know oxygen having the electronic configuration 2, 6. What is oxygen negative? So they having the electronic configuration beta 2, 7. Okay, they having the electronic configuration 2, 7. So how will they form? So they will make only single bond, whether they will make a double. Right. So this is the structure. So how will you draw the structure of this? So this double bond may be here. This double bond may be here also, right? So we can say that. Let me draw the resonance diagram of this. So we have Cl double bond, and one having single bond, right? So chlorine having 2 to 4 to 6, 2 to 4, right? So fluid having 1 electron, 2 electron, 3 electron, 4 electron, 5 electron, and 2, that is lone pair of electron, right? So they having the 7 electrons. Now, will you write the resonance diagram? Like, how will you write? That is, this will become C, this will become your double bond, this will become, this oxygen become negative, and this oxygen become double bond, right? एक और तरीका है लिखने का, बताओ जल्दी कौन सा? That is C, इसको कर दो, इसको कर दो सिंगल, ये रहा डबल, ये रहा डबल, ठीक है जी? ये रहा डबल, और क्लोरीन पे तो है ही एक लोन पेयर. So total we have a three ways, one way, two way, and the three ways, right? So this is how will you draw. And let me write their conical form. So conical form को कैसे लिख देंगे? That is Cl and this with oxygen, 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 like that. Right. So this is the conical form of. Okay. So this is the conical form of ClO3. Now, how will you calculate the bond order? So we know we can calculate the bond order by using the formula, that is the number of bonds between Cl and O. Number of bonds between Cl and O. Number of bond between Cl and O divided by total number of oxygen, that is the surrounding atom. Okay. So bond order is equal to number of bonds between Cl and O divided by the total number of oxygen surrounding by the atom. So we know the total number of bond between chlorine and oxygen is how much? That is 1, 2, 3, 4, and 5. So this is 5 divided by total number of oxygen surrounding atom. So we have only 3. So we can divide 5 by 3. So 5 by 3 comes out to be 1.67. Yes, this will comes out to be 1.67. So this is the bond order. समझ आया? So ये क्या निकल के आया हम लोगों का? Bond order निकल के आया. So this is how will you calculate the bond order for the particular compound. ठीक है? तो ये तरीका होगा हम लोगों का bond order को find out करने. So I hope this is clear. How will you calculate the bond order? Similar, if the case of O3 negative ion, O3. So in O3, how will you draw the structure? So you draw the structure like oxygen, double bond, oxygen. In the next step, oxygen, single bond, double bond, oxygen. This is the structure only, na? We draw for the ozone. So here the number of bond between Cl and O. So number of bond between Cl and O is how many? That is 2 and 1. That is 3. So this is 3. And the total number of O, that is surrounded. So kitne hai? That is 2. So we can say that 3 by 3. That is 1.5. So bond order comes out to be 1.5. So this is how we can actually calculate total number of oxygen atoms, surrounding atom. ये को तो सेंट्रल आइटम मान लिया ना, तो कोई सराउंडेड है तो 3/2, that is 1.5. Now, if you know this thing, then you can actually calculate the formal charge as well. So how will you calculate the formal charge? So the atom of a molecule or ion usually are neutral, that is carrying no charge, right? The atom of the molecule or ion are usually neutral. They do not carry any charge. However, for some purposes, such as to find the reaction mechanism, assigning of formal charge of atom in the molecule or ion is very important. Thus, formal charge is calculated. So how will you calculate this formal charge, beta? So we can calculate this formal charge, and formal charge like valence electron minus lone pair of electron plus half bond pair, right? So this is how we can actually calculate the formal charge. So formal charge is like valence electron minus lone pair plus half of bond pair. right? So this is how you can actually calculate the formal charge. Let me explain this with an example, right? Suppose we have to calculate the formal charge of O atom in the ozone molecule. So let me draw the structure. How will you draw the structure for this? Hmm? So we know that ozone having a structure like this. O, this is O. So this is the structure of ozone, and you have to calculate the formal charge. So let me write the name here. This is oxygen number one, oxygen number two. This is oxygen number three. So if I want to calculate the charge on oxygen number one, what is the formula we use? That is the valence electron. Okay? Valence electron. So oxygen having valence electron 6 minus lone pair of electron they are asking. So here we have two lone pair, here we have three lone pair, here we have one lone, right? So lone pair. The lone pair of electron we have in oxygen one, that is 4. Okay? So we have a lone pair of electrons. The lone pair of electrons, total number of non-bonding electrons on lone pair is equal to 2 plus half of BP. That is half of bond pair. So plus half of bond pair. तो bond pair कितना है? Lone pair तो मिल गया, दो पेयर थे, that is 4 इलेक्ट्रॉन, 2 into बॉन्ड पेयर कितना है? दो बॉन्ड बना रहा है, मतलब 4 इलेक्ट्रॉन. तो ये कितना आ गया बेटा? दैट इज 6 माइनस ये हो गया 4, that is 6 minus 6, that is equal to 0. So they have equal to 0 charge. तो फॉर्मल चार्ज कितना आया ऑक्सीजन नंबर 1 पे? तो ऑक्सीजन नंबर 1 पे फॉर्मल चार्ज आया है C. Similar, if you want to calculate the formal charge on oxygen number 2, you can calculate it. Again, the formula is same. Like valence electron is what? That is 6. So 6 is the valence electron. Now next is lone pair of electrons. So on oxygen number 2, we have a 2 to 4 to 6 lone pairs plus half into. So half into, here we can say that bond pair. So they're making only one bond pair. So in one bond pair, we have only two electrons. So this is 2 out of 2. This will be cancelled. So this will get 6 minus 6 plus 1, that is 7. So 6 minus 7, that is minus. So they having minus 1 charge, right? So they having minus 1 charge. So 0 minus 1. Similar, if you want to calculate for oxygen number 3, you can calculate as, how will you calculate for oxygen number 3? Again, valence electron is 6 minus lone pair of electrons. How many lone pair of electrons they having? Again, they having only two lone pair of electrons, right? So they having the 2 plus half into bond pair. So they will form 2 bond and 3 bond total. 2 bond with oxygen 1 and 1 bond with oxygen 2, 3 bond. So 3 bond we have 6 electrons. So we have a 2 and 2, 3. So this will come out with 6 minus 5, which is equal to plus. So these are the formal charge of oxygen atom in the ozone. That is 0, minus 1, plus. Okay. So these all are the formal charges of oxygen atom in the ozone molecule. So I hope this is clear to you कि किस तरीके से हम लोगों ने ओजोन मॉलिक्यूल के अंदर फॉर्मल चार्जेस को फाइंड आउट किया, राइट? सो दिस इज हाउ वी कैन एक्चुअली कैलकुलेट फॉर्मल चार्ज ऑफ ऑक्सीजन एटम इन ओजोन मॉलिक्यूल. ठीक है, चलो. So this is the solution of this question as well. So we also solve the question like this only. So this is the correct representation of the ozone molecule, like +1, -1, and G. Okay. Now, the formal charge for each atom in the sulfuric acid is equal to. So you need to calculate the formal charge of each atom in the sulfuric acid. So this is the homework question for you all. Try to solve this question, right? Try to solve this question. You have to calculate the formal charge of each atom in sulfuric acid. Okay. Sulfuric acid, that is H2SO4. So you need to calculate all this. Now, move to the next thing, that is hybridization. What do you mean by this term hybridization? So basically this process involves the mixing of orbitals of almost similar energy, right? Belonging to the same atom to form the same number of orbitals of exactly equal energy. The new orbital formed are called hybrid orbital, right? So the new orbital here formed are called hybrid orbital. This phenomena in actual sense involve redistribution of energy. So this is the important thing. The phenomena in actually sense involve redistribution of energy. So this is the key point here. So what is hybridization? The process of involving mixing of orbital almost similar energy, or we say when the older orbital mix together, they form the newer orbital of the having the some new number of orbitals exactly equal means, right? Now the new orbital formed are called the hybrid orbital, and the phenomena is actual sense involving redistribution of energy. So this is all about the hybridization. Now, what are the silent feature of the hybridization, or the we say rule of hybridization? Okay. So only the valence and atomic orbital of an atom or ion can mix together to give the hybrid orbital. This is very important. Only the valence cell atomic orbital, not all the electron, only valence cell atomic orbital of an atom or ion can mix together to give the hybrid orbital. Now, the atomic orbital of the atom of a given molecule or ion which participated in the formation of pi bond remain excluded from the hybridization process. So this is a very important thing. That is the atomic orbital of the atom of a given molecule or ion which participate in the formation of pi bonds remain excluded from the hybridization process. Now, if the central atom of the given molecule or ion also has one or more lone pair of electrons, then the atomic orbital having lone pair of electrons, that is completely filled orbital, are also taken part in process of hybridization. Now, in few cases, empty orbital are also involved in hybridization. So this is also very important thing. That is, the empty orbital are also involved in hybridization. Okay, like B2H6. Okay, now the hybridized orbital have exactly equal energy with identical size, shape, or we say hybrid orbital are degenerated. So degenerated orbital are those orbital having equal amount of energy and the identical shape and size. Okay, now the hybridization can be of the following type, either sp hybridization, sp2 hybridization, sp3 or dsp2, sp3d, or we say the D1 sp3, or we say sp3d2, or we say sp3d3. So out of these first three are described in your syllabus, that is sp, sp2 and sp3. Okay. So what are the first method for writing the hybridization of the bond? Right. So write the electronic configuration for the outermost orbit or the central atom. For example, if you want for CH4, just write the electronic configuration of the central atom. So here the central atom is carbon. So write the electronic configuration. 1s2, 2s2, 2p2. So these are the electronic configuration of the central metal atom. Find oxidation state of the central atom. So what are the oxidation central atom? Excite the electron from orbits of the higher energy in such a way that the total number of unpaired electron it must be equal to the oxidation state of the central atom. So here the oxidation state of the central atom is +4. Hmm? So we can write as yeah, this is 2s2. They having 2p2. This is in a ground state, right? Now in excited state, how will you excite? Excite in a such a way that the total number of unpaired electrons must be equal to the oxidation state of the center atom. You already know oxidation state is +4. So how will you excite the electron in the excited state? देखो एक इलेक्ट्रॉन यहाँ, एक यहाँ है, एक यहाँ है, तो यहाँ का एक इलेक्ट्रॉन आगे चलेगा ये, तो कितना इक्वल हो गया 1 2 3 4, तो अनपेयर इलेक्ट्रॉन 4 है, इससे ज्यादा एक्साइट नहीं कर सकते, उससे कम कर सकते हो लेकिन ज्यादा नहीं। सो एक्साइट कितना हो गया +4 हो गया, तो यहाँ पे साफ साफ दिख रहा है कि हाइब्रिडाइजेशन क्या होना चाहिए, एक एस का ऑर्बिटल है और 3 पी के sp3, so orbital will be sp3. So this is the one method. How will you calculate the sp3? How will you calculate this? Right. So this is the first method. Clear है? समझ आया सबको कि किस तरीके से निकाला फर्स्ट मेथड? चलो, और द सिमिलर वे right? On the similar way, you can also calculate this for the any other thing like NH3. For NH3 also, if you want to calculate the hybridization of NH3, then how will you calculate? So for the NH3 also, you can calculate like this. Okay. So for the NH3 also, you can calculate like this. ठीक है, चलो दिखाएं कैलकुलेट करके फटाफट कैसे निकालोगे. Yeah, let me explain this SF6 as well. So this is the SF6. What is the maximum oxidation state here? So the maximum oxidation state is +6 for the sulfur. Right. So this is the sulfur electronic configuration, that is 1s2, okay? 1s2, 2s2, 2p6, 3s2, 3p, 1, 2, 3, 4. Right. दो दो चार से दस दो बारह चार 16. So 3p4 we have, right? So we are taking the valence electron only. So we have a 3s, 3p, and 3d also having 0 electron. So this is 3s, 3p, and 3. So this is in a ground state. Now in excited state, we have 1 electron. How will exercise? We excite in such a way that the number of unpaired electron must not be more than the oxidation state. So we have a 6 oxidation state. To excite 1 electron here, and this 1 electron here also. So we have a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 6. So we have got the 6 unpaired electron, which is equal to the oxidation number of this. Right. So this is the 6 electron we have. So their hybridization become 1s, 3p, and 2d. That is sp3d. Okay. sp3d2. So this is how we'll actually find this. Okay. So इस तरीके से हम लोग actually में इसको apply कर सकते. I hope this is clear to you. फटाफट बताओ, क्लियर है सबको एक बार? हम्म, ठीक है. So this is how will you calculate the hybridization. So this is the first one. The second method is very simple. Yes, sir. The second method is also a very simple one, right? How will you calculate for the second method? It's a very simple, and I personally use this method. If you solving MCQ question, then this method is very good. For example, if you want to calculate the hybridization of any screw, then just use steric number, right? That the formula for calculating is number of sigma bond plus lone pair of electrons. Just you need two things. So here we can say that the number of lone sigma bond in this NH3. So NH3 having 3 sigma bond and lone pair. So I'm having 5 electron, 3 bond, 2. So one lone pair is 4. So 3 plus 1, 4. 4 means sp3. Okay? 4 means sp3. So this is another, and it's a very short method, right? For example, if you want to calculate for H2, then also here we can see we have oxygen, we have hydrogen. So number of sigma bond we have 2. Number of lone pairs. So we have a 2 lone pair in this, and oxygen having 6 electron. Out of this, only 2 electrons are being bond with hydrogen. So they are left with 4 electrons. That means 2 lone pair. So 2 plus 2. So again ये कितना आ गया 4. And 4 means क्या हो गया बेटा sp3. So this method is also very simple and very quick method. We can say that. Just you need to calculate number of sigma bond plus lone pair. So if you know this number of sigma bond and lone pair, then you can easily calculate. क्लियर है क्या सबको? ये जल्दी बता दो एक बार. Number of sigma bond plus lone pair. चलो. So this is how we can actually calculate this. That is number of sigma bond plus lone. ठीक है? Okay. So we already covered many of the topic. The last one is the Vesper theory. And so in tomorrow class, basically we're going to solve numerical related to the Vesper theory. Numerical means question, right? These all are the theoretical chapters. So in this, no numericals are there. Wherever I say numericals means we have to solve previous year question related to this topic, right? So Vesper theory. So what is the main postulate of this theory? The first important point is the central atom in the molecule contain two types of electron pair. These are bond pair and lone, right? So central atom molecules contain होते हैं दो types of electron, bond pair and lone pair. The shape of the molecule is determined by the repulsion between all the electrons pair present in the valence shell. A lone pair of electron takes up more space around the central atom than a bond pair, since the lone pair is attracted by only one nucleus, while the bond pair is attracted by the two nucleus. Therefore, the lone pair takes more space. Thus, presence of lone pair on the central atom causes slight distortion of the bond angle from the ideal shape and capability from the hybridisation. Right. So we are going to solve a question related to vector theory in tomorrow class. Today already time is completed. So in tomorrow class we are going to see this. So if you have any doubt related to today class, you can ask. You have 1 to 2 minutes left. You can ask me. Anyone having any kind of doubt? Because tomorrow we are going to start from this Vesper theory, right? And try to solve some question. No, all are clear. ठीक है? नो सर, चलो फिर थैंक यू ऑल. कल मिलते हैं एंड कल करेंगे फिर इसको कंप्लीट.